since I wrote this one. So the first thing I want you to do is to write an introduction about hypothesis testing and its importance in science. So you've all done hypothesis testing? Yes? What would you say it is? How could you explain it? Yeah. What do you think? What would you say a hypothesis test is?
Testing something that proves to be wrong?
Yep, that's it. Yeah, you could say it's testing to see if something could be right or wrong, true or false. Yeah. And you're all science, aren't you? No? You're health science, yeah. So science or health science, yeah. So this is very, very, very important for you, because whatever papers you will be reading at university, whatever science papers you read or whatever research you're reading, they'll all contain hypothesis tests. Like, it's an absolute minimum maths knowledge for science. And it doesn't matter if you're doing chemistry, medicine, whatever. It'll all have hypothesis testing. So that's why I made this coursework, is to get you seeing a hypothesis test like in a paper, like this. So anyways, you can do a little bit of research and just write a definition of hypothesis testing and why it's important in science and all of this. So now on to the maths. So before that, I need somebody's data. So do you have the data there? Does anybody have some data I could use to do this? I can't do anything without data. I need data. Okay, alright. So what's the 284? PL, is it?
Yes.
Okay, so that's PL. What's the next one?
20.
Wait, big P or small P?
Big P.
Big P and
Purple round 20.
Huh? Show me. I don't know.
Purple long.
What the heck is that? Oh, purple! Alright. No, that's fine. Sorry. Your U sounded like an O, so I thought you were saying Popalong. I was like, what the heck is Popalong? Purple long. Okay. Thank you. So purple long, 284. And then purple round. Okay, so that's small l, isn't it? 20. And then 20 for red long. And then 55 for red. You did? But it doesn't matter. No, it doesn't matter. It doesn't matter, because once I have some numbers, that's all I care about. And the last one is purple round. So just big L is long. Small l, I think, is round. Big P is purple. And small p is red, or something like that, isn't it? Yeah. Right. So, this is the only thing I need your help with, because I don't study biology, to make the Punnett square. So, I hope you're all good at biology. How do we make the Punnett square here? So, just forget about this for a moment. So, what have we got here? Write the 4x4 Punnett square. Okay, and you have 1,000 of these. P, L. So, I really need your help here now. What way does this go? Is it like... Yeah, how many boxes should I have?
4.
I should have 4. Thank you. Like this? Okay.
No, spot sign.
Okay. Like this?
Yeah.
Is this enough? Okay, what do I put here? P?
No, like
Like what?
Four more
like
lines.
More lines?
yeah.
Alright, how many more?
There's like 16 boxes there should be.
16
Oh,
boxes?
16, yeah.
Alright, okay. Are you sure?
It's a dihybrid one. So.
Okay, I trust you. I trust you, okay. 16 boxes.
Yeah.
So how many? That's not enough, is it?
1, 2, 3, 4, yeah.
Are you sure it's this many?
1, 2, 3, 4. No, the last two you put, they're not supposed to get there.
Do you know what? Much easier. You make the table and then show me what you get. It's a little bit of biology revision to start with. Oh yeah, sure, I say it here, 4 by 4 square. Okay, I should read my own question, it'd be helpful. Now this is interesting because I'm seeing two different types of tables. Fahad, isn't it? No, I forgot your name.
Abdullah.
Abdullah, not Fahad, sorry. Abdullah, do you know how to make this table?
I do.
Can you make it? Well, but you said you know how to make it.
I can.
You can make it.
Yes.
Can you make it now?
Yes.
Okay, thank you. And what about for you?
Yeah, I mean,
You made it? Do you think you're right? How confident are you? Okay. I'm going to open up the internet and we can check the answer. Okay, you have it made.
Yeah.
And are you confident with this?
It should be the dihybrid one too.
Yeah, correct. 4 by 4 rather than the other one is 2 by 2 or something?
Well, yeah, because now this has two different characters that we're using, so.
Yes, okay. So you think you have all
It should
16 there?
Yeah, it should be 9 to 3 to 3 to 1. Yeah.
Oh, good. Okay. So, what do I write up here? This is big P. Thank you. Big P, big L, and then the next one is big P, small L. Small P, big L. Small P, small L, and then here the same thing.
Yeah.
P L, P L, P L, P L, like this. No, I don't need to check the internet. I trust my students. It's okay. Right. Oh, come on, you piece of junk. Anyways, while that's trying to fix itself. So, we have to fill in the 16 boxes. Now, the things I really care about, I want to know if it's purple, long, purple. Oh yeah, okay, what's the expected ratios? Okay, let's fill this in. Right, so what do I put in here? Do I put the 4 of these, isn't it?
Mm-hmm.
Yeah. I don't think I need to do all of these, do I? So this is PL, PL, and I do this for all of them, isn't it? No? No, there's only 2 in here.
I mean, you put the 2 P's and then the 2 L's. So big P, big P, big L, big L.
Oh yes, big P, big P, big L, big L. I take one of each, isn't it?
Mm-hmm.
So this one would be big P, and
Big L and little L.
big L, little L, and then big P, small p,
And
big L, big L.
There should be small p and big P.
No, I think I
Single letter? Like,
but I feel like this is the right one. No,
It's correct.
yeah. Now, please remember, the last time we did biology was 14 years ago. So, and you did this probably 4 weeks ago. So, you know, I'm trusting the class on this one. Okay, the next one is big, small, big, small.
Yep.
Okay, and it continues like this. Okay, so now, I'll just write here, etc. Okay, obviously in your report, you should finish the table. So that's part B. Part C, what is the expected ratios? Okay, so if I look at these 16, I have to count up how many of them will be purple. So, for example, this will be purple, yeah? 1, 2, 3, 4. And will everything here be purple because of the big P here? Yeah, so that's another 4. Okay, so I have 4 and 4. And then what about on this one? Yes, yes, and then that's it.
No,
These aren't purple. Yeah, well, I'm sorry, when I say that's it, I mean for that row. And then the next row, yes, yes. 8, 9, 10. Is it 12? Did I do that wrong?
It should be, the ratio should be 9, 3, 3, 1 at least.
9, 3, 3, 1. Okay, so I've gotten too many with 12, is it? Yeah, count them up for me. 4, 8, 8. Oh, hang on. It's here. It's not. Yeah, that's not quite right. 1, 2, 3, 4. Yes? Okay. How many here? 1, 2. 2, 3, 4. Yeah. How many here? 1, 2. How many here? 1, 2 as well. That's 12.
what can there be to under 1 to 3 draw?
9 are the purple long. So,
Oh, sorry. I should be counting purple long. I was just counting purple. Fool. All right. Foolish of me. Right, sorry. Purple long. Okay, and then the next one we'll do is, what's the next one? Purple round. And then red long. And then red round. Okay, that's much better, right? Okay, so how many purple longs here? 1, 2, 3, and 4. Okay, that's better. And how many in the next one? This is purple long.
Yep.
1.
that's
Not.
No.
that is,
That is.
No.
Not so 2. Okay, so we continue like this, and thank you. You said you have the ratio already, so it's 9 of these. There'll be 3 of these boxes, 3 of these boxes, and 1 of these boxes. Okay, great. So that's the hard part for me. Everything else now will get easier. So we have the expected proportion for what we should observe. Okay. What is the theoretical ratio? Done. Okay, so we're already on to part D now. What is the theoretical expected number? Okay, so 1D. 1 part D now. So how many of these plants do I have in total? How many do I have in total? It says it in the question. Is it 1,000? You bred 1,000 of these. Yeah? Okay. So I have 1,000 of these plants. So how many do I expect to be purple long? How many purple round? How many red long? And how many red round. And the ratio is 9331. So in other words, I want to split my 1000 into 4 numbers. So I want the ratio. Do we remember how to do this? So you might have to think back. You did it a very long time ago. Think about who your maths teacher was when you were 12 years old. All the way back then. You do need, yeah, divide by what though? Who was your teacher when you were 12? Now think back. You know, and it would have been done as a sweet question. Somebody has sweets they want to share in the ratio of 9331. What do we do first? Divide by the sum, yeah. So 9 plus 3 plus 3 plus 1 is 16. So what I need to do is divide this by 16 and then multiply it by 9, 3, 3 and 1. So can you type in 1000 divided by 16 and then multiply by 9? What do we get? Okay, 62.5. Next one.
Oh, it's 6 times 9.
Yeah, times 9. What is it?
562.5.
562.5. And the next one, 1000 divided by 16 times 3? 187.5, and then 187.5. And the last one, 1000 divided by 16? 62.5. So that's how many you expect to get. You expected 562 purple long. Okay. We have already finished task 1. Task 1 is now complete. I don't think there's any questions on task 1. If anything, I should have questions for you on task 1, not the other way around. So now we'll go on to task 2 then. Yeah. Okay, can I scroll down? Yeah, I'll need these numbers now for task 2. Okay. The ratio of the 4 phenotypes differ from what's expected in task 1D. Construct a table containing both the expected and the observed number. Okay, so here's my table. Here's my 4 phenotypes. Purple long, purple round was the next one, was it? Yeah. Red long and red round. I expected and I observed. Okay, I expected 562.5, I expected 187.5, 187.5, and 62.5. How many did I observe? Well, that depends on my data, because I gave each student different data. Okay. Now, you gave me some data at the start, so I'll use data that's similar to it. So 284, 2020, 55. So we'll say 284, 20, I'll change it a little bit, I'll say 19 and 56. And this is my data. Okay, this is different for everybody. So this here will be different for everybody. Construct the table containing, yeah, that's it for the first part, task 2A. Task 2A. Okay? Now, of course, when you type this up in your report, you know what you need to do. You need to put a caption on it, you know, table 1, the expected and observed number of phenotypes. You know, like you do this type of stuff in biology, you know, Colm loves his captions and everything being proper and, you know, like this, yeah. But mathematically, that's all it is. Okay, will we go on to the next task 2B now? Okay, so this is task 2B. Form the null hypothesis and alternative hypothesis. Alright, now we're getting juicy. What's the null hypothesis here? I'll write H null. So, you've done hypothesis testing. The null hypothesis is kind of like the status quo. So, before this experiment was done in biology, what was the assumption of how phenotypes behave. And I think this comes from, what's his name, the fellow with the peas. What's his name? He did this in biology. He bred the peas. What was the... That's the guy, yeah, Mendel. So what was the basic hypothesis, the null hypothesis with the phenotypes that Mendel observed? Like there's some assumption about how the phenotypes behave. I can't remember what it is. Do you know it? It's something about the interaction with them. So some type of independence.
The domain or something?
Something like this. Anyways, it doesn't matter because we can write the null hypothesis as a mathematical statement. So the null hypothesis is that the ratio is 9, 3, 3, 1 for purple long P L and PL. That's the null hypothesis, that the ratio should be this. Now, you can look this up if you want to put some biology in it. You might want to research why should the ratio be this. Well, we got the ratio from the Punnett square, but we're assuming, we're making certain assumptions about this Punnett square in biology that turns out not to be accurate. It worked for Mendel when he did it with the peas, but actually when you do it for other situations, it turns out not to be true. I think it has something to do with the position on the DNA strand for where these...
Position on chromosome.
Position on the chromosome, thank you. If they're close enough together, when they combine, there's some kind of interaction, so the behavior is not independent. So there's some kind of interaction. But Mendel assumed that there's an independence, so it means Mendel's Punnett square, if Mendel was doing this, he would make this Punnett square, and he would get this ratio. Okay, so that's what we were expecting, but that's maybe not what we get. So the alternative hypothesis is that it's not this ratio, basically. It's not 9 to 3 to 3 to 1. Okay, can we go on to the next part? Now, please, you have to type up a report, so you need to put more in it than just this. So you need to check that fact I said about the chromosomes, what exactly it is and what Mendel assumed and so on. Okay, task 2C. What is the degrees of freedom? So, what is the degrees of freedom for this table? Now, I don't know if you've done this in... do you know how to get the degrees of freedom?
Number of rows minus 1 times number of columns.
Very good. Number of rows minus 1 times number of columns times 1. In this one here, what would it be? So number of rows minus 1 times number of columns minus 1. So it would be 4 minus 1, which is 3, times 2 minus 1, which is 1. So the degrees of freedom here, the DF is, we said, 4 minus number of rows minus 1 times number of columns minus 1, which is 3. Yeah? There is another way to do the degrees of freedom if you prefer. You can think about it like this. It's the number of things that you can change. Like if you think about what the word means, freedom, you know, change it. So if you think about this experiment, think about it like this, as an experiment. This is not from the experiment, okay? This is from the hypothesis. This is the data you collected, isn't it? Oh, sorry, I said that wrong. This is the data you collected. Now look at the freedom in the data. Could this number be different? Yeah, of course it could. Maybe if you did the experiment and you did the experiment, you get a different number. So that's 1. Could this number be different? Yeah, so that's number 2. Could this one be different? Yeah, that's number 3. Could this one be different? No, actually. And the reason not is because you must have a total of 1,000. So as soon as this number, and this number has been fixed by the experiment, because the total has to make 1,000, you can't choose anything for this number. Like for example, you couldn't have 100, 100, 100, 100 and 1,000, because then that would give you 1,300, but you only have 1,000. So once this is 100, 100 and 100, this one has to be 700, because the total we said is 1,000. So how many numbers could change? Only 3 numbers could change. And that's the same as the formula that you used a moment ago. Okay, so 3 is definitely the degrees of freedom here. Okay, will we go on to 2D now? Yeah. 2D. What is the critical value? Okay. Chi critical. So what we have to do is we have to go to our table book where it has degrees of freedom equal to 3, and what is the usual probability value that you use for these hypothesis tests?
10%?
Some people use 10, it's usually 5. You have 3 common ones, 1%, 5% and 10%. 5% is the most common. If 5% is not stated, you could use 1, 5 or 10. It's just for most papers, most people when they're doing a test use 5% as the value. So does you have the formula book? Yeah, can we go to the chi-squared and let's see what it is. Oh, here it is. It's on the back. Okay, so if I look at 5% and 3, I get 7.81. There you go. Now what does that 7.81 mean? Well, the way it works is like this, just to remind you. So if your calculated chi is bigger than the critical value, this leads you to reject the null hypothesis. However, if your chi is less than the critical value, then you do the opposite. You do not reject the null hypothesis. What do you do with the equals? I don't know, because that never happens, and I don't want to think about what to do. I know what the answer will be because of the design of the assignment. So let's calculate and see what happens, even though it's not going to be a surprise to me, and maybe not to you. Okay, so, if I take the formula book back again, we can look up the formula for calculating chi. It's in the formula book. You might actually know it. Do you know what it is? It's the sum of expected minus observed, yeah? Squared.
No, divided by e squared.
Divided by e squared? Is it like this? Well, look, it's in the formula book if you don't know. So, did you find it? Here, I'll show you where it is, huh?
Divided by e.
Yeah, not e squared. Yeah, correct. Okay, let's calculate it now. So I need to have my table, which I can't see right now. So I'll do the calculation up here beside the table, because I can't see right now. So you would need to do 562.5 minus 284 squared over expected, 562.5. That's the formula. And then you have to add it and do the same thing for the next three. Okay, calculate please, if you add those four together. So just to remind you, it's expected minus observed squared over expected. Got that? I'm expecting a big enough number as your final answer here. Yes, quite a big number. 137.8. What did you get?
28.
Okay. Yeah, okay, yeah, if you round it off. So it's a pretty big number. 137.88, wasn't it? So 0.9. Okay, great. What's next? Right, so what's the conclusion here? What's the conclusion? Yeah, since 137.9 is much bigger than 7.81, that leads us to reject the null hypothesis. So the assumption that we should have 9331 ratio is rejected. Clearly, we do not have that here. Okay, so the assumption by Mendel is not true anymore. We don't get the 9331 according to the Punnett square that we expected to get. Yeah. Okay, so next part now. Now, this is where I'll need your help. What the heck is a recombinant phenotype? Do you know?
What is recombinant?
But
Recombined.
phenotype is not like the parent type, isn't it? Isn't that what you said?
State the number of observed recombinant and the number non. So, I suppose my question is, I think of these four, which ones are the recombinant and which one are the non-recombinant?
3 and 1.
Which are the P? Which one here?
And last 2 on the right.
The last two are what ones? Combined or not recombined? Yeah, I don't know. I was hoping you would know.
They both were purple, right?
Yeah.
And last 2 are not purple.
But is it? Yeah, but it's not necessarily for purple.
So something that wasn't big P, big L, and because we began with 2 pure breeding lines, so anything that wasn't the parent are the recombinant.
Anything that isn't the parent.
The parental genotype was the 2 double big P and double big L, and then the recessive.
Okay, so which one here would you say is the, as you'd say, the recombinant that isn't the parent? Or am I thinking about this the wrong way?
No, I think we
The two middle ones would be not recombinant.
No, they would be
Recombinant, okay. And then
I
the
think. I don't know. He said that just like fleetingly in the class just once.
I think we need to take them from Punnett square. That's
from the Punnett square.
I think.
Oh, okay.
We have the final.
Oh, I see. Okay, so you think we should be looking at the Punnett square to count how many of each there are?
Probably 25%.
Oh, I see. Okay, the percent. Okay. Let's try and figure this out. State or the number of recombinant and N or non-recombinant. Do we need to Google something on our phones, perhaps? Yes. Okay. Can you do a quick Google to see? I'm sorry, I thought you did this in biology. This was something that was just made in.
He mentioned it just then, like once, about recombinant stuff.
But I think you're saying we should be looking at the Punnett square. And which one do you think is which? Oh, if you have something in your notes, that'd be wonderful.
Just checking if there is maybe.
Yes.
We can just finish the Punnett square on Sunday.
Yeah, but what am I counting, I suppose? Like, for example, the first one here
It's not complete.
is not recombinant.
Yeah.
Why not? Explain to me. I want to learn.
It was like the parent, right?
I guess so. I don't know.
So it's not like the parent. So the same genotype was the parent.
Oh, I see. So, recombinant.
If it has this meaning, then this is true.
Okay. I like it. I think you might be right. So, recombinant means you want it to look like the parents.
You say that.
No, you're the biology expert. I'm not the biology expert. You agree with this? You've checked it on Google. Great, okay. So, let's count it up now. So, we seem to have the opinion that recombinant means the child looks like the parent. Right, so how many of those 16 squares does that happen? Which one is the parent? Big P, small p, big L, small l, is it? Okay, so how many of those do we get? Big P, small p, big L, small l. So let's write it out. The first one, yes or no? Is it like the parent? No. 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 Yes. Yeah. Okay, that's one. This is the only child that's like the parent. Yeah, isn't that what I'm counting?
Recombinant ones are the ones that are not like the parent.
Like, yeah, like the parent.
Okay, it doesn't matter. We can figure out which name is which. We'll just count up first how many are like the parent.
I thought the parents are the ones were the pure breeding line. So
Are they?
you began with 2 pure breeding lines. Wait, and then which generation?
The first phenotype, PPLL, PPLL.
F1 generation.
This,
All offspring. Wait, which one are we looking at?
we're looking at F2 from F1, and F1 is PPLL. Big P, small p, big L, small l.
Oh, okay. They are
Yes.
heteros.
Yeah.
Okay.
Okay, the next one. How many are like the parent here in the next one? No, no, yes, no. So this, okay, so I can, is that the next one? No, yes,
No.
no, yes, 2 yeses?
No.
That's a no, so just one as well. Is it one on each row? It's kind of looking like it. Yes. No, okay. Right, so we have 4 that are like the parent and...
5.
Is it 5? I thought there was only 1 here.
So it's 2.
Is it 2? No.
Only 4.
I must have miscounted. It's only 4. This one? Yes. No. No. Okay, yeah, so there's 4 like the parent and 12 not like the parent. Right, now, which one are we saying is like the parent? Recombinant or not recombinant?
Recombinant. I checked that on the
Yeah, the recombinant is the mixture, so it's not like the parents because it's different.
So recombinant is not like the parent.
Yeah, it's a new genotype.
Parents and not parents. You see, you're at the backward. We have disagreement here. So you're thinking I should put it 4 here? Recombinant is like the parent?
Shouldn't be.
So you're thinking 12-4 like this? Well, I suppose the easiest thing, do you have anything in your biology notes that says this? I tell you my opinion. I would have thought the word recombinant means you make something that looks like the parent, because it's recombined to make.
Yeah, but the definition says otherwise.
The definition is the other way. Show me the definition if you have it there. Recombinant phenotypes are the phenotypes of the offspring that differ from that of the true breed and generation parents. So recombinants differ to the parents, is what it says here. So these ones here are not the parents. Yeah, so it is like this. Now, if you disagree, that's fine. Just, you know when you have to put your sources in, whatever definition you're using, just make sure you have the source for it. Yeah. And please, don't trust me on this. This is biology. This isn't my area. Okay? Right. State the number of observed and the number of non-reserved. Okay, so we're not quite finished, but maybe we'll just finish there today, but we'll just do this one last thing. We want, not the ratio here, but I want to count how many observed recombinants and non-recombinants there were. Okay. So, if I look here, let me remember, not the recombinants are not like the parents. Okay, which one of these for recombinant, non-recombinant, not the parents is the 12, which is the, so not like the parents. Okay, so which one of these here are not like the parents? Oh, I'm sorry, I just don't know anymore. I've gotten too much biology for one morning and I can't think straight. How about we stop there and I'll leave it up to you to investigate your biology to double check this and then we can continue. So, I'll just give you a little bit of a homework. So what I'd like you to do is to type your report from 1A to 2F. And then I want you to try 2G. And I want you to be able to explain 2G to a simple maths, physics teacher. So you should be able to explain to me next time exactly what recombinant and non-recombinant is, okay? I also encourage you to ask Colin to check any of this, okay? Because I designed this with Colin. So he did the biology part and I did the maths part. So he is very familiar with this coursework. So if you get stuck on this, I would welcome you to ask Colin about the biology parts, okay, the recombinant and the non-recombinant stuff. Do you have biology today?
Yeah.
We have, great. So you can ask him because I think the whole class would actually like a bit of a discussion on this biology class, yeah? Okay. Oh no, it's not quite confusing, it's very confusing, just to be clear.